In this video, we want to learn how we can graph polynomial functions. For graphing polynomial functions, it's important that we check the polynomial is even degree or odd degree. When the polynomial is even degree, the two ends of the polynomial, the graph of the polynomial, are going upward or are going downward. If the leading coefficient, please pay attention, if the leading coefficient of a polynomial is positive, in the case of even degree, the two ends are going up. If the leading coefficient is negative, the two ends are going down. In the case that a polynomial is odd degree, for example, if a polynomial is y equals x to the 3 plus other terms, because it's x to the 3, it's of degree 3, it's odd, then one end is going up, the other end is going down. They go in opposite direction. So when a polynomial is odd degree, the two ends are going opposite direction. One end going up, the other end is going down. When the leading coefficient is positive, right end is going up, left end is going down. When the leading coefficient is negative, left end is going up, right end is going down. So this is important and you have to keep this in your head. For example, suppose we have a polynomial in the form of y equals x to the 4 plus other terms. Because the degree of the polynomial is 4, we suppose 4 is the highest degree in this equation. Because the degree is even and leading coefficient is positive, it's 1 here. So it's this case. And immediately we know that the graph should be something like this. The two ends are going up, and between these two ends the graph can go up and down. How we can find these points, these x-intercepts? For finding the x-intercepts, we have to factor the polynomial. And let me show you an example with odd degree. Suppose we have a polynomial like negative 5x to the 7 plus other terms. Immediately we notice that this polynomial is of odd degree. And because the polynomial is odd degree and leading coefficient is negative, so we know that it's this case. The right end is going down, the left end is going up, and between these two ends the graph can go up and down. Something like this. And the number of x-intercepts depends on the factored form of the polynomial. Now that we are familiar with the end behavior of the graph of polynomial functions, let's do some examples together. Look at this example. Y is given x plus 4 times x plus 1 times x minus 3. Immediately we check for the degree of this polynomial. This polynomial is of degree 3. How we know that this polynomial is degree 3? Because we have this bracket which is x times x times x, it would be x to the 3. Each of these brackets have a power of 1, and the terms inside these brackets is of degree 1. So we have 1 plus 1 plus 1, so the degree of this polynomial is 3. Immediately, because we know that the degree is 3 and leading coefficient is positive. Why it's positive? Because if you pay attention, here the coefficient here is positive, and inside the brackets also we have x, 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 no negative, we have 4x. So we know that the leading coefficient is positive. This is other thing that we have to check. Now that we know these things, leading coefficient is positive. We know that it is this case. Left end is going down, right end is going up, because leading coefficient is positive. So let's back to our question. Immediately we know that the right end is going up, left end is going down. What about between? For finding the behavior between these two ends, we have to set the polynomial equal to 0, and we have to find the x-intercepts. So we have to set x plus 4 times x plus 1 times x minus 2 equal to 0. When we set this equal to 0, each of these factors should be 0. So from the first one, x is negative 4, from the next one, negative 1 and 2. So these are the x-intercepts. So the x-intercepts are negative 4, negative 1, and 2, if we suppose 2 is here. And again, don't forget, the left end is going down, the right end is going up. So we start from the left, we start going from here, passing through the x-intercept, simply crossing the x-axis, and this is the graph of this cubic polynomial. Attention, if the polynomial is not in the factored form, first you have to factor it to find the x-intercepts. We will see examples that are not factored form, but this example was in factored form, so it was easy to find the x-intercepts. Let's do another example. F of x is given negative 4x times x plus 3 times x minus 1 to the 2 times x minus 4. What is the degree of this polynomial? We have a degree 1 here, a degree 2, a degree 1, and attention, we have x here with degree 1. So the degree is 1 plus 1 plus 2 plus 1. So the total degree is 5. So this polynomial is of degree 5. But attention, this polynomial leading coefficient, leading coefficient is negative. So this polynomial is of degree 5 with leading coefficient is negative. Now we have to find the x-intercepts. For finding the x-intercept, each of these factors in this factored form polynomial, we have to set them equal to 0. Simply, by setting this equal to 0, we get 4. By setting this bracket equal to 0, we get 1. By setting this bracket equal to 0, we get negative 3. And by setting negative 4x equal to 0, x is 0 over negative 4, or x is 0. So the x-intercepts are negative 3, negative 1, negative 2, negative 3. This point is here. 0, then we have 1 as another x-intercept, 2, 3, 4 is somewhere here. So we know that whatever we have to graph should pass through these points. Based on the degree and leading coefficient, the degree is 5. When the degree is odd in general, we know that the two ends are going in opposite direction. But because leading coefficient is negative, the right end is going down, the left end is going up. So we know that the right end down, the left end up. Now we start again from the left, passing through these points, and we can graph the function. The first point that we have to pass through is negative 3. So we go toward negative 3. Then we get to 0. We have to pass through 0. Try again, we have to pass through 0. Now when we get to 1, we want to pass through 1. Please pay attention, this is very important. This factor is raised to the power of 2. When we have it in the factored form, a factor with even degree, with multiplicity 2, when we have a root with multiplicity 2, or when we have a repeated factor, and it is repeated twice or 4 times, even times, please pay attention, when we have a factor that its power is even, then we should not simply continue to that point and cross x-axis at that point. It's very important. When we have such a factor, the graph bounces at that point. Let me explain this here to you. Remember graph of x to the 2. X to the 2 has x-intercept 0. But when we want to graph this curve, we know that its curve is like this. Its graph is like this. Are we crossing x-axis and we go through x-axis? No. When we get to x-axis, we bounce, as you can see. So here we have to do the same thing. When we have x-intercepts, that those x-intercepts are factors with power 2, power 4, then when we get to those points, we go toward the x-axis, we touch x-axis, and we bounce at those points. Here, 1 is such a point that has multiplicity 2. So, when you want to graph, again, let me explain this to you. We go through 1, we go toward 1, but we are not crossing as usual. We bounce at 1. So, the graph would be something like this. We go through other routes as usual, but when we get to 1, we bounce. Now we have to continue. We know that we have to pass through this point as well. And at the end, we have to go this way. So now you should be able to graph the other part of the polynomial. So this is the graph of our polynomial. Something like this. And maybe you wonder how much we have to go up. To figure out these things, you need to be familiar with the calculus, and you have to use derivative to find the maximum and minimum. But this is not the topic of this video. You go up a little and then you back to this point. And at this moment, we don't know exactly how high we have to go or how low. When, for example, here you draw this, how much we have to go down, then we have to pass through 0. We cannot answer these questions at this moment, and our focus in this video is not on this. So, we learned something new here. When we have a factor with multiplicity other than 1, here we had x minus 1 to the power of 2, then at those factors in the graph of the function, we have a bounce. Look at this example. G of x is given x times x minus 1 to the 2 times x plus 2 to the 3. What is the degree of this polynomial? This polynomial is of degree 1 plus 2 plus 3 is 6. The power of x is 1, here is 2, here is 3, so the total is 6. So this is even degree. And as you can see, the leading coefficient, the coefficient of x is 1, it's positive. So leading coefficient is positive. Now we have to find the x-intercepts and then we can graph the function. If we set this equal to 0, x is negative 2. By setting this equal to 0, x is 1. And by setting this equal to 0, x is 0. So we have 3 roots. 0. If we suppose 1 is here, 2 is here, 3. Negative 1, negative 2, negative 3. One root is negative 2 at this point. The other root is at 1, this point. These are the roots. Because the leading coefficient is positive and the degree is 6, so it's even degree. In even degree polynomials, the two ends are going same direction. Leading coefficient is positive, so the two ends are going up, positive side. They go upward to the infinity. So we know that the left end is going up. The right end also goes up. And we know that we have to pass through these points. But how we have to pass through these points? 0, please pay attention, 0 is a simple root because x to the 1. But 1 here is of multiplicity 2. So at this point, at 1, we have to have a bounce. Maybe this way or this way. But we have to have a bounce at 1. But something is unusual about negative 2 as well, because it's with power 3. It's not with power 1. It's odd degree. And this is the first time that we see something like this, that a factor has multiplicity 3 or multiplicity 5. What is the difference? Is there any difference or not? Please pay attention. Do you remember graph of y equals x cubed? Its graph is something like this. It crosses x-axis at here, but it gets a little flat at 0 and then continues up. It doesn't simply crosses x-axis like this. And for example, another example, if we look at the graph of, for example, negative x plus 2 to the 3, its graph crosses x-axis at negative 2. But when we graph this, it's like this. As you can see, when we have a factor with odd degree, it crosses. By odd degree, I mean bigger than 1, not 1. 1 is a simple root, and it crosses x-axis simply like a line. But when we have odd degree, we go toward x-axis. We do not bounce, but it becomes a little flat, then it continues same direction. It doesn't change the direction at that root. So let us start. Negative 2, at negative 2, which is this point here, we expect to see that behavior. We go toward negative 2, but when we go toward negative 2, we know that we have to graph something like this. Something like this. We should not simply graph like a normal curve. We should not cross as usual. So the graph would be something like this. We go toward negative 2. Then, what about 0? 0 is a simple root. So we know that we have to go toward 0 as usual. Then, about 1, we need a bounce, something like this. So let me try again to graph this a little better. So our graph would be something like this. This is the graph of this polynomial. So the things that you have to attention more is this point 1, which we have a bounce. This is a usual root. We cross the x-axis as usual. And about negative 2, as you can see, we go toward negative 2. We get a little flat like this. Then we continue going down. Let's continue to our next example. Here we have a polynomial of degree 4. But the problem here is that our polynomial is not in the factored form. So immediately we notice that the degree of this polynomial is 4 and leading coefficient is negative. Leading coefficient is negative. But the main problem that here we have is that we have to factor this polynomial. Because we need to know the x-intercepts, then we can graph the polynomial. For finding the x-intercept, we have to factor this. By looking at the terms, immediately we notice that x, and actually negative 2x, can be factored from all the terms. Why I prefer to factor negative 2x, not 2x? Because when we factor a negative and we put it outside, the remaining factor would be with a positive coefficient. So it's better to factor the negative because leading coefficient has a negative. So as the first step, we write p of x in the form of negative 2x times x to the 3 plus x to the 2 minus 10x plus 8. So we factored a negative 2x. Then we have x to the 3 plus x to the 2 minus 10x plus 8. Now, for this remaining cubic factor, we have to use factor theorem and integral zero theorem or rational zero theorem to find the other factors for this cubic polynomial. Because the constant term is 8, please pay attention, because the constant term of this polynomial is 8 and this leading coefficient is 1, so immediately we know that the possible factors for this polynomial are these numbers, plus minus 1, plus minus 2, plus minus 4, and plus minus 8. What are these numbers? These are the factors of 8. The factors of 8 are plus minus 1, plus minus 2, plus minus 4, or plus minus 8. And based on integral zero theorem or rational zero theorem, we write these factors, and we know that these are the possible factors for this polynomial. But which one is actual factor? Which one is the zero for this polynomial? We have to check, of course. We plug in 1, we plug in negative 1 to see which one is an actual factor. Let me name this f, then I plug in f, then I plug in these numbers inside f. Is f of 1 0? If it is 0, then x minus 1 is a factor for this polynomial. If not, we have to check other numbers. If you plug in 1 inside this polynomial, it's 1 to the 3 plus 1 to the 2 minus 10 plus 8. 1 plus 1 is 2, 2 plus 8 is 10, 10 minus 10 is 0. This is a good news, because now we know that x minus 1 is a factor for this polynomial. Now that we know one of the factors of x to the 3 plus x to the 2 minus 10x plus 8, we use synthetic division and we divide this by x minus 1 to find other factors. If you remember synthetic division, we draw something like this. This is the method of synthetic division. 1, 1, negative 10, 8 are the coefficients of this polynomial that we have to write down here. And from this binomial, we put the opposite sign of this number always here in the synthetic division method. If you are not remembering the synthetic division method, watch my video about synthetic division method, or watch the intro video for polynomials. Based on synthetic division, we write 1 here, we drop that number. 1 times 1, we multiply this by this, is 1. 1 plus 1 is 2, we multiply again 2 by 1. 2 times 1 is 2. Negative 10 plus 2 is negative 8. Negative 8 again times 1 is negative 8. 8 plus negative 8 is 0. First of all, as we expected, we got 0 as the remainder. It should be 0 because we know that x minus 1 is a factor for that polynomial. So when we divide that polynomial f with x minus 1, remainder should be 0. Now by looking at this quotient, we know that it means that we have x to the 2 plus 2x minus 8. So this can be written as negative 2x times by x minus 1 times by x to the 2 plus 2x minus 8. We factor this polynomial in this form. X minus 1 is a factor and this is the quotient. Now this quadratic function, quadratic expression that here we have can be factored easily in this way. Negative 2x times x minus 1 times by x plus 4 times x minus 2. We are looking for two numbers that their product is negative 8. The sum is 2. Those numbers are 4 and negative 2. This is the way that we factor quadratics. We put 2x here and here. We look for two numbers that their product is this. Their sum is 2. Those numbers are 4 and negative 2. Now that we have the factored form of polynomial px, it's easy to graph this polynomial. We draw x-axis and y-axis. Then we put the x-intercepts. X-intercepts are 0, 1, 2, and negative 4. Negative 1, negative 2, negative 3, negative 4 somewhere here. Here is 1, here is 2, and here is negative 4. And please pay attention. All of these roots, all of these solutions are of degree 1. All the brackets are power 1. So we have nothing with multiplicity 2 or 3. So these are all simple roots. And because the degree is even, leading coefficient is negative. When we have even degree, the two-end behavior of the polynomial is this. The two ends are going same direction. Even degree, same direction. Odd degree, opposite direction. This is even degree, so the two ends are going same direction. But which direction? Because leading coefficient is negative, that direction is down. So we know that the left end is down, the right end is down, and we have to pass through these points by curve. And so our graph would be something like this. This is the graph of this polynomial. Now look at this question. X to the 5 minus x to the 4 minus 8x to the 3 plus 12x to the 2. This is odd degree, this is degree 5. And leading coefficient of x to the 5 is 1, it's positive. This is the first thing that we have to consider. So the degree is 5, it's odd degree, and leading coefficient is positive. But for finding the x-intercept, we have to factor this. It's easy to see that we can factor x to the 2 from all the terms. Then we have x to the 3 minus x to the 2 minus 8x plus 12. For factoring x cubed minus x to the 2 minus 8x plus 12, again we use factor theorem and integral or rational zero theorem. Because here we have 12 and this coefficient is 1, so the possible factors for this polynomial are in this list. We have to write down all factors of number 12. Plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. Let me name this here again f. Then we have to calculate f of 1. If it is 0, then x minus 1 is a factor. If not, we have to check other numbers. Is f of 1 0? If we plug in 1 inside f, it's 1 to the 3, 1 minus 1 to the 2, 1 minus 8 times 1 minus 8 plus 12. This is not 0. So we know that 1 is not a solution, is not a factor. We check for negative 1. What about f of negative 1? If we plug in negative 1, then we have negative 1 to the 3, negative 1 minus negative 1 to the 2, it would be again minus 1. Minus 8 times negative 1 would be plus 8 plus 12. Is this 0? No, it's not 0. So we check for the next number, 2. Is f of 2 0 or not? We have 2 to the 3, 8, minus 2 to the 2, 4, minus 8 times 2, or 16, plus 12. 8 minus 4 is 4, 4 minus 16 is negative 12, plus 12 is 0. Because this is 0, immediately we know that x minus 2 is a factor for this polynomial here. We use synthetic division, we write down the coefficient 1, negative 8, 12. And what number we have to write for synthetic division here? That number is, yes, it is 2. Based on the synthetic division, we write 1 here. We multiply 1 by 2, it's 2. Negative 1 plus 2 is 1. 1 times 2 is again 2. Negative 8 plus 2 is negative 6. Negative 6 times 2 is negative 12. 12 plus negative 12 is 0. And remainder is 0. It should be 0. This means that the quotient is 1x to the 2 plus 1x minus 6. So this means what? This means that this can be written as x2 times by x minus 2, this factor here, times by x to the 2 plus x minus 6. x to the 2 plus x minus 6. And this can be written again as x to the 2 times x minus 2. Can you factor x to the 2 plus x minus 6? We look for two numbers that their product is negative 6, their sum is 1. Those factors are x plus 3, x minus 2. 3 times negative 2 is negative 6, 3 minus 2 is 1. Now that we have the factored form, we can graph our function. By setting this equal to 0, x is 0. By setting the next bracket equal to 0, x is 2. By setting the next bracket x plus 3 is 0, x would be negative 3. And by setting x minus 2 again equal to 0, we have this root again. So attention, we have 2, 0 and negative 3. Please pay attention, x minus 2 is repeated here and here. This means what? This means that 2 is a repeated factor. 2 is of multiplicity 2 because it's x minus 2 times x minus 2. And x minus 2 times x minus 2, it basically means that we have x minus 2 to the power of 2. So, 2 roots, 2 of these numbers are of multiplicity 2. 0, please pay attention to this, 0 from this factor. X to the 2, it means that x times x, so this is a repeated factor. So we have to see as bonds at 0. And also because x minus 2 is a repeated factor, because we have 2x minus 2 in our factored form. So at 2 we will see a bounce in the graph. The degree is 5. So it means that one end is going up, the other end down. But which end up, which end down? Because leading coefficient is positive, right end is up, left end is down. We start from the left and we go to the points. Remember, negative 3 is a simple root, simply cross x-axis. But when you get to 0 and 2, you have to bounce. You have to see a bounce in your graph. So the graph would be something like this. We go to root 3 as usual. When we get to 0, we draw a bounce, another bounce at 2, and as we expected, we go up. This is the graph of this polynomial of degree 5. I hope by watching this video, you have learned about graphing polynomial functions in the factored form or in the standard form. If you like this video, please subscribe in my channel and see you in the next videos.